All right, so this, instead of calling it nonlinear functions, we're going to go with parabolic functions. Anybody ever heard the word parabolic? You've heard it, Noah? Okay, what does it mean?
I don't know. I just heard it.
Okay, you've heard it. Okay, anybody ever heard of a parabola? Okay, all of the functions that we have done have been linear, right? Meaning that when you graph them, they all formed a what? Straight line. Okay, let's do, just as a quick refresher. Okay, let's say that, okay, if I was to graph, let's say I had a function, let's say one of the ones you had last week was something like this, y equals x plus 2, something like that, right? Okay, if I asked you to graph this using a function table, okay, you give it your own values, right? You give it your own values. And how many points do you have to have for a function? It's said on the video, it's 4, right? Okay, so if I did that, if I have a function table, I put x here, and then I put my rule. Remember, this is like the microwave, okay? Y equals x plus 2. That's going to give me my y, which in turn is going to give me my xy's, right? My points on the graph, okay? Now, always the easiest one to start with, and this will hold true for today's lesson also, is 0. Okay, if I make x 0, y equals 0 plus 2. What's 0 plus 2? 2. So this first point would be 0, 2, right? Right? Okay, if I did 1, y equals 1 plus 2, y equals 3. Okay, this would be 1, 3. If I did negative 1, y equals negative 1 plus 2. What's negative 1 plus 2?
1.
1. Okay, so far I've already got 3 points, right? What's another point I can use?
2.
I can use 2, okay? So if I do 2, y equals 2 plus 2, what is that? 4. Okay, so does everybody understand how I got my 4 points? Everybody understands. All you got to do is plug them in, right? And I can put x equals 53, and it's still going to be on that line, but why would I not want to use 53? Why would I not want to have x equals 53? Why, Sarah?
Because it'd be too big and it'll be off the graph.
Yeah, you're going to have a ginormous graph, okay? It's still going to be on that same line. If I graphed x equals 53, the y value would be 53 plus 2, so the y value would be 55, okay? At the point 53, 55, it's still going to be on that line. It's just going to be way off the graph. Okay, does that make sense? So let's graph these 4 points. If I have 0, 2, over 0, up 2, right? Over 1, up 3, back 1, up 1, and over 2, up 4, okay? Did those form a straight line? Yes, they did. Therefore, this was a linear function, okay? Does everybody understand why they call it a linear function now? Yeah? Okay, so we're good on that, right? Please speak up if we're not. Are we good on that? Okay, good. All right, so when we go back to nonlinear functions, these are going to form a curved line, okay? They're not going to be linear, okay? So when you have something, you have an equation that looks like this. Make sure you're writing this down. Let's say y equals x squared minus 1. Okay? What do you notice is different about this? Kemper. There's a square value on the x, okay? When you see a square value, when I see this right here, what that means is it's nonlinear. It can't be linear, okay? That means my line is going to curve, okay? Does that make sense? Now, depending on whether it's positive x or negative x, this x is positive, it's either going to curve up or it's going to curve down, okay? But we're still going to make our own function table. The only difference is you have to do 5 points because one of them has to be 0, okay? Let me explain what that means, okay? So when I make my function table, and you're going to have to make your own function tables. There's not room for it on your worksheet today. So you're going to have to do that on a separate sheet, okay? I'm going to make my function table. So I have x. What goes here? Does anybody remember? The rule, right? Okay, the function. Okay, so this is y equals x squared minus 1. What goes next?
Y,
Y. And then my last one is going to be what? xy. Okay? This is the template you should use every time you make your own function table. Okay? Is there anybody that doesn't understand what we did there? Now I'm going to put my values in. Now, with a linear function, I can put anything I want. Okay? With this one, you want to be pretty consistent on what you put. When you put an x value, you have to also put its opposite value. Well, let me show you first. The first one you always start with a nonlinear function is 0. So I'm going to put a 0 here, okay? 0. Y equals 0 squared minus 1. Well, that's easy. What's 0 squared? 0. And what's 0 minus 1? Negative 1, okay? So my first point is 0, negative 1, okay? Always start with 0, right? Okay. Now, let's plug in another point here, okay? Now, you want to be conscious of what you're putting in. Now, this one's easy because these are small numbers. But if I have these really big numbers, okay, I don't want to use numbers that are giant to get off my graph, okay? Kemper, question.
Last week, our sub, I didn't understand one worksheet,
Uh-huh.
and she was trying to help me, and I still don't understand it, but she told me to put a negative 0 on something. And I was like, no, first of all, there's no negative 0.
Okay. Yeah, don't worry about it. All right. So what we're going to start with, okay? In this case, this one's easy because it's a small equation. We can just use 1. But what you have to do with a nonlinear function, anytime you have a squared value, I'm going to put a 1, but I also have to do its opposite, okay? So this is going to say y equals 1 squared minus 1. Well, what's 1 squared? Don't say 2. What's 1 squared? 1. What's 1 minus 1? 0. Okay. So this one is 1, 0. Agreed? Now this one I have y equals negative 1 squared minus 1. Well, what's negative 1 squared? Don't say 2. Don't say negative 1. What's negative 1 squared? Negative 1 times negative 1 is 1. And 1 minus 1 is also what? 0. What do you notice about this? What do you notice about this? Your y values are the same. Remember, in a function, you cannot have the same y values, can you? Okay. All right, so what are we going to use next? We got to do 2 more. We can get all crazy and do 3, or we can play it safe and do 2. Let's play it safe. All right, fine. So we do 2, but if I do 2, what do I also have to do? I also have to do negative 2. Okay? So I have y equals 2 squared minus 1. 2 squared, that's a tough one. What's 2 times 2? 4. 4 minus 1 would give me what? 3. Now, let's think about something here. Do I already have my answer because I'm doing the opposite? I already have my answer for my y value? I think I do, but let's just see if it's true. Y equals negative 2 squared minus 1. What's negative 2 squared? Negative 2 times negative 2 is what?
4.
Positive 4. 4 minus 1 is what?
3.
Did I already have it? So yes, negative 2. Do you see a pattern that you can make things a lot easier on yourself here? Yeah. Okay, so let's graph these. Okay? Did everybody write those down? Because I don't want to go back and forth. Does everybody write those down? Okay, Jordan, what's my first point? My 0 point?
0, negative 1.
0, negative 1. So my first point is going to be right there. Okay, what's my second value?
1, 0.
So over 1 up 0. What's my next value?
Negative 1, 0.
So back 1 up 0. What do you already notice? That this is not what? It's not linear, is it? Okay, keep going, Jordan. What's my next one?
2, 3.
Over 2 up 1, 2, 3. Okay. What's my next one?
Negative 2, 3.
Back 2 up 3. Okay. So when you graph this, okay, your line is going to go like this. Okay, that's what we call a parabola. Okay, it's a curved line. Does that make sense, what we did? Okay, when you have a squared x, it's always going to be a parabola. Okay, how wide it is depends on the value after the x. Whether it's going upwards, it depends on the value of x is positive or negative. Samir, are we good?
Yeah.
You're looking at me all cray-cray.
No, no.
You mad dogging me?
Maybe
All right, yeah. I don't want to cross you, fool. All right. Okay, did that make sense? Sort of, a little bit, maybe? Not really?
Yes.
Kinda? Okay. Let's try another one. All right. Let's say, can I erase all this, guys?
Sure.
Everybody get it? Okay. So let's say I'm going to take one from your worksheet. Okay. let's say I've got something like this. Okay. I have an equation y equals negative 3x squared plus 3. Okay. You think it's going to change how we do this? No. Not at all. Okay. So I'm going to make my, what's it called, function table. Make my table. So I have an x value. Remember, what is x also known as my, rhymes with flinput? Input. Wow, you guys are sharp. Good. Okay, so input, and then this is my rule. Y equals negative 3x squared plus 3. What is the y the same thing as my what? Outputs. Taking the Hot Pocket out of the microwave, right? Then over here I have my x, y. Everybody understand how we set that up, right? Okay, let's go. Let's do this. So I have x. What's the first one I have to start with, and it's nonlinear? Got to start with 0. Okay, so let's put a 0 here. So y equals negative 3 times 0 squared plus 3. All right, what's 0 squared? 0. What's negative 3 times 0? 0. What's 0 plus 3? 3. So my first point is going to be 0, 3, isn't it? Right? Yeah? 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 Okay, good. All right. What do we want to do next? 1? Okay. Let's do 1. Y equals negative 3 times 1 squared plus 3. Well, what's 1 squared? Now, if you need to write this out using order of operations, I'm fine with that. But I think you're at a point where you can do this in your head. What's 1 squared? What's 1 times 1? What's negative 3 times 1? What's negative 3 plus 3? 0. Are we okay on that? Now, what did you learn last time? Have to put the opposite. Okay, but no matter what, what's negative 1 squared? 1. What's negative 3 times 1? What's negative 3 plus 3? 0. If you have one of these, do you already have the other one? Yes, you do. Okay? Which one should we do next? Are we living on the edge? Or are we going to go conservative? 4. No, it's crazy. All right, fine. Let's do 4. Okay, so y... Oh, no, dude, 4 is going to be huge.
No, please, do like
Let's do 2.
2.
Do 6.
Okay. All right, y equals negative 3 times 2 squared plus 3. What's 2 squared? 2 to the second power. 4. What's negative 3 times 4? Negative 12 plus 3. You owe me $12, you pay me 3. Negative 9. Now, do we really have to go through all that work this second time around? What did you notice, guys? Every time I do the opposite number here, my y value is always the exact same thing, isn't it? Okay, so I can put negative 2 squared plus 3, but I guarantee you it's going to be what? No. Because negative 2 squared is 4. Negative 3 times 4 is negative 12. What's negative 12 plus 3? Negative 9. Right? Can we graph these? Did you write them down? Yes?
Yeah.
Okay. Let's go graph them. What's the first point, Jordan?
0, 3.
0, 3. So I'm going over 0, up 3.
And then 1, 0.
Over 1, up 0.
Negative 1, 0.
Okay. What's my next one?
Negative 2, negative 1, 2.
2, down 1, 2, 3, 4, 5, 6, 7, 8, 9. And then back 2, right there. Right? I'm going to make my perfectly straight line. Like that. Okay? Does this make sense? So if you're going to solve one of these problems, if I ask you to graph a problem that has an x squared, what are you going to have to do first? Make a what? Jackson? Well, you're going to have your graph already. What are you going to have to do, though? Make a function. Come on. Table. Okay. Once you've done that function table, you start with what? 0. Then you have whatever point you use, you have to also use its what? Opposite. Okay. Easy enough, right? Now, something I want to show you. On your graphs are like this. They're not numbered, okay? So if you come up with numbers that are really big, okay, you can change this so that you count these. Let's say these are 2. I can make this 2, 4, 6, 8, so that I can fit more data onto a smaller graph. Could I do this? Could I do 3, 6, 9, 12? You could, okay? That's totally fine for you to do that.